Our aim, how do we find the sine, cosine, and tangent ratios of a right triangle? So our first question we have is going to be, what type of triangle is triangle ABC if the sides are AC is 5, BC is 12, and AB is 13? Let us now label our diagram. AC is 5, BC is 12, and AB is 13. When trying to figure out the sides of a triangle, using the sides of a triangle, we know one theorem we use normally is something called Pythagorean Theorem. Pythagorean Theorem will help us show whether a triangle is a right triangle or not a right triangle. We're going to square all the sides and basically the sum of the squares of the two smaller sides. Here we'll have 5 squared and 12 squared. And we'll test to see whether or not it is equal to the longest side, 13 squared. We calculate 5 squared to be 25, 12 squared to be 144, and 13 squared to be 169. If we add 25 and 144 together, you get 169 equals 169. This works out. Therefore, triangle ABC is a right triangle. In this case, our right angle looks like it'll be right here. And our largest angle in any triangle will always be opposite the longest side. We see the longest side is AB, and therefore the largest angle will be angle C, opposite of the longest side. The smallest angle will be opposite the smallest side. Here, our smallest angle will be angle B, because opposite the smallest side here, 5. Now, what is the measure of angle B? That we have to figure out. And we're going to be using, in this case, different ratios of the sides of a triangle. We call them trigonometric ratios. So let's now take a look at them. But first, let's just talk about the different parts of our right triangle. There are ratios of trigonometric ratios are the ratios of the sides of a right triangle based upon the angles. Here, this symbol here is referred to as theta. And so theta in this case will represent the angle we're going to look at. If sort of almost like a variable for angles. From this angle theta, we have the leg opposite to the angle. Leg opposite to the angle. Label O. Here, this is the leg adjacent to the angle. Remember, keep in mind, these are legs. The hypotenuse is the side opposite of the right angle, and there's not going to be a leg. So we'll call this A, and we'll call this H. It's a good idea when trying to use trigonometric ratios to label which one is the leg opposite, which was the leg adjacent, and the hypotenuse based upon the angle they give us. So, for our ratios, we have 3 ratios. The sine ratio, the measure of the leg opposite over the measure of the hypotenuse. The cosine ratio, the measure of the leg adjacent over the measure of the hypotenuse. And the tangent ratio, the measure of the leg opposite over the measure of the leg adjacent. We sometimes use phrases or little tricks to remember which one is which. One way is using Sohcahtoa. You'll notice in this case there are 9 letters, really triplets in this situation, and each of these triplets represents the ratios we have here. We have S sine is equal to the leg opposite over hypotenuse. C cosine is equal to leg adjacent over hypotenuse. and T tangent equals leg opposite over leg adjacent. So in case you want to take a look. So, 3 ratios, and all based upon the angle we have. Let's go back and look at our do now problem. Our do now problem we had was here. And so we're going to erase this, and we're going to now find, in this case, the sine ratio, the sine of angle B, the cosine of angle B, and the tangent of angle B. First, the sine ratio. We know it's going to be the measure of the leg opposite over the hypotenuse. And here's angle B. The leg opposite is 5. And the measure of hypotenuse, 13. So that's going to be our sine ratio. Our cosine ratio for B, angle B, will be the leg adjacent over hypotenuse. That's going to be 12, leg adjacent to angle B here is 12, and hypotenuse is 13. And the tangent angle B is leg opposite over leg adjacent. We find leg opposite is 5, and the leg adjacent is 12. But we don't always take it from one particular angle. It could be from another angle. In this case, angle A. Let us take a look at the sine of A. And the sine of A, notice the angle here, A, now has a different angle opposite. Okay, the leg opposite actually, the leg opposite over hypotenuse. Here, our leg opposite of angle A is 12, while hypotenuse stays the same as 13. Our cosine of angle B is the leg adjacent over hypotenuse, but this time from angle A, our leg adjacent to angle A is 5. Hypotenuse is still going to be 13. And the tangent of angle A is equal to the leg opposite over leg adjacent. The leg opposite of angle A is going to be 12, while the measure of leg adjacent to angle A is going to be 5. And we see in this case there's something that comes up here. So it comes up, we notice that the 12 over 13 is the same value here. So the sine of A equals the cosine of B. And the cosine of A equals the sine of B. We have a special name for these things because we see in this case they both have the same value, but we don't know what the angle measures are. Well, to find the angle measures, what we're going to do is kind of talk about them, their relationship. Let's take a look. Here, we don't know what the measures are. We do know this is 90 degrees. And here, for this situation, angle A, we call this, I don't know, X, and we call measure angle B, Y, and this is 90 degrees. We know the measure of angle A plus the measure of angle B plus the measure angle C equals 180 degrees. Well, X plus Y plus 90 equals 180 degrees, which if we subtract 90 from both sides, we get X plus Y equals 90 degrees. That means the angles are,
at this time, this is the last opportunity
measure angle A
for anyone who needs additional
plus measure angle B
to come down
is
to
equal
the
to 90.
conference room for today. Again, this is the
And that's the relationship we have in this case. Measure angle A plus measure angle B equals 90 degrees. So if the sine of A equals the cosine of B, then the measure of angle A plus measure angle B equals 90 degrees. They're called
And Google support in the conference room,
code
Capital Learning, in
functions.
the Spolman's office, and schedule of pupil tasks is in 153. For those of you who need devices to